So the next part. So this is something that I was showing in the economic session the last time. The idea was to take a NORM model. It's a North Sea offshore field, and the simulation model, as it comes, it has some this scenario, which is a drilling plus workover, drilling some wells that were drilled plus some workovers on those wells, plus a terrace, which is a small producer here on a small volume with an injector, and water and alternated injection of water and gas. So the problem that we had when we were doing the economic session is that these models were on history mode, and so we want to forecast with this model. So on this next session, what I'm going to show you is generating a forecast from an Excel file or from a table that you could have, and with some codes that I have written. The first step is showing you the actual input, the schedule input on the file that will be produced from this Excel, and then after that I will do some more additions with some more edits with some Python functions to make things a bit more interesting. But if you see here, what we have is we have some wells specification. So we have some wells with some IJ and some information about the wells, drainage radius, and so on. We have a completion information for the wells. In this case, this is something that you, of course, will get from preprocessor. But really, this can be something that you can define very quickly, vertical wells. But as you can see, we have when the wells were started or when the wells were completed, what is the completion information about the well. And there is a bit more of information, which is the group tree, which is this is more related to ECLIPSE organization of the network in the surface. I'm not going to go to the details, but also I have, this is a prediction in terms of how I would like to structure the prediction. So I have a well, this is alternating between gas and water. For the time being, forget about these 4 tabs, and let's focus on the actual first 3 tabs. And then I will generate these last few tabs automatically with Python. But what is it that we want to do? So we have this Excel, and we want to end up with a file that more or less looks like this one, right? So on this file, this is ECLIPSE file, I have a well specification. So it means that I have 3 wells, D1H, B2H, C4H. So which happens to be D1H, B2H, and C4H, which is somewhere down the line. I don't know, here. And those 3 wells were completed on the 31st of October 2022. And which happens to be the first simulation time step. Actually, let's take the next time step, which is this one. 11th of December 2022. Again, this is a prediction. We are establishing a prediction. We want to test different development scenarios for this asset. And so on December 2022, the well D2H was completed. So that's D2H, December 2022. There we go. And we also have the completion information. So for the well for the COMDAT, the well D2H, and the well D2H, here it is, was completed on December 2022 with this completion information. So I want to produce that file with this Excel. Again, this is a very good example where you may want to have an Excel that has it's very formatted and you want to generate an ASCII file. This is of course with a simulation file, but it can be with anything really. So now let me show you. Let me migrate. I'm going to do this Jupyter. And let me store this. This is going to be on the reservoir simulation, and I have put together the schedule and a scheduled case here, schedule writer case here. I am going to share that input Excel, and I'm going to share the writer. So this writer, it's what is going to do the magic of writing the file. And for this writer, actually take that data frame, take some the keyword list or the keywords that you want to print, and the name of the file that you want to save to. So first, in the first step, I'm going to just use a writer, and then I'll show you what's happening on the background. Actually, let me delete these files because I was testing before. You don't need to see those. Just a second. Excuse me. Yes, apologies. So I want to use that file. I'm going to create here a schedule writer. Let me rename this as schedule writer. And I'm going to import this writer first. And let me read with pandas this input file. I'm going to read the well specs, the com.dat, and the group tree. So the way I'm going to do it is with pandas. Import pandas as PD. I'm going to have a data frame. In fact, let me have a dictionary here. So this is going to be all keywords to export. And this is going to be a dictionary. And the first thing that I want to do, it's in the dictionary, I'm going to store my well specs. I'm going to read with pandas. I'm going to use read Excel. I need the file. The file in this case, it's going to be the input or input.xlx. So I'm going to read that file. And in this case, I'm going to read the well specs. So I can put that my sheet name, it's equal to well specs. Okay. So if I show you that, all keywords to export, it has that well specs. already loaded. Now let's automate this a bit because I want to store everything in one go. So let's see, the keywords that I want to load are, I'm going to load some keywords, not all of them, but I want to load well specs, com dot, and what else we would like to load here. For the time being, dates and group 3. Actually, let's put dates. Dates cannot spell dates. And group 3. Just I'm using the name of a keyword in Eclipse as it's been used in Eclipse. And now I'm going to do a loop here for keyword in some keywords. I want to store in this dictionary. I want to read this tab. Okay. Now, if I read this, I have my well specs, I have my dates, my com dot, and the group 3. Okay, that's fine. And in fact, I can just bring the dates, or I can bring the com dot, and I have everything in there. Now, what I'm going to do now is use the writer, and the writer, it's very simple. It takes the file that you want to write, and it takes that df is actually the dictionary and the keyword list that you want to print. So if I use the writer, let me take this out. I can use a writer and say writer dot schedule writer, and I have the file, and let me write the file that I want to write here. This is output file. Output file. I want to write on my include folder here. So this include folder that is empty. So I believe it will be something like include, and for the time being is first export dot whatever dot include. So this auto file is going to be taken by this function, and I'm going to pass also these all keywords to be exported, and I'm going to pass also finally the keyword list, which in this case is some keywords, not all of them, some keywords. So let's see what happens there. Okay, so I'm going to the next error, which is same thing. So I think the days and the month and the rows, so this is coming as a number, and I think this has to be converted to a string before I can print it into a file. So let me convert this to a string and convert this to a string. Okay, it's printing. It's printing. It's fine. I have a file, so it's going over the. Let me remove this and open again. Oh, there we go. Don't know what happened there. I think the first issue was that I needed to clean the kernel when I'm editing the file. it kind of led me to believe that the file was read again, but in fact, yeah, I have experienced that before. You have to clean the kernel when you change those files that you are importing. And if I want to remove that print that I don't really like to have there, again, clean the kernel, run again. So this should disappear, all that print. Shouldn't have any error. Oops, and now I have this print. Okay, but this is something that I was doing just to illustrate. So if I go in here in the first export, now I have the dates, the well specs, and the contat and the group tree. So I have all those three keywords. And as I mentioned, just to close it up, I want to create, add more keywords to the mix. In this case, I would add, let me see here, automate generation of the wconimg, wcomprot, gcomprot, and gconimg. And okay, now what I would like to do is generate these other keywords in a more automated fashion. So I would like to all these keywords to export. In fact, all these keywords to export. I will need to add somehow these new keywords. Okay. And the way I'm going to do it, I'm going to generate few functions just before this. I'm going to generate a function called W. Let's start with the easy one, which is a gcomprot. And the way I'm going to generate a gcomprot is just double check. No. So on the gcomprot, I would like to set up oil rate, and this is going to receive an oil rate. It's going to receive a water rate, and it's going to receive also a gas rate limit for the facilities. And I could, because I could have multiple gcomprots. First, I'm going to generate hold on a second. Okay, first, the one thing that you can see here is that I have a template where I have all the keywords, all the mnemonics used for the keywords in Eclipse. And I'm going to make use of this one. So if I do, for instance, writer dot, and I access the master dictionary, and then the gcomprot, I see all these vectors that I need to to add. So one thing, I'm going to create here a dictionary. Let's create a dictionary here. And also, let's bring this value into something called this item. I'm just going to bring this. And one thing that I would do is for every one of these keywords, I would like to set a default. And as you know, the default in Eclipse is if you want to default a mnemonic, you can put 1 star. So similar to what you have in the Excel, if I show you the gcomprot, there are some 1 stars here. So I would like to put 1 star on those keywords where I don't have any values to specify. And then override, I'm going to override these other keywords. For that, I'm going to do for item, in this item. So for every one of those items, I'm going to start to populate this dictionary with the item name, and I'm going to set it to 1 star. So Eclipse will take, in this case, a default value. And then I would start to use other keywords, which is one for oil rate. But first of all, I can set up also a group. Let's call let's say where the well is producing from, which is in this case which group. So I'm going to take the group and set this value up. And I'm going to take also the target type, and this is target. It's going to be a target type. And the rest of the things that I'm going to do, it's oil rate, water rate, and gas. Let me copy this 2 times. Oil rate, or at W rate, and gas. And I always need also a date for this. So in the oil rate, I'm going to set the oil rate here, the water rate here, the gas rate here, and the date, it's also something that I could pass on right here. And now I'm going to generate a data frame. And I'm going to set up my columns equals to this item. Well, I can probably set straight away create a data frame with this dictionary, but I'm going to do it like this because in WCONINCH, for instance, we will see that we'll have many more items. So then my data frame gcomprot, it's going to be equal to df gcomprot dot append, and I can add this dictionary, and I have to ignore the index, otherwise we'll have an issue with the. Okay, and I'm going to return this data frame gcomprod. So this function, if I use that function, and in fact, let's put for the time being only gcomprod on the list. And what I would like to do is add to the all exports to the dictionary. I would like to add gcomprod. So now I can run my gcomprod function. Return this temporary data frame. This data frame, I'm going to store it in here. The group, it's I'm going to put this field. The target, it's going to be 30,000 cubic meters per day. The rate, it's going to be the water rate. Oh, sorry, this is the target type. So this is 30,000. The target type, it's going to be controlled by oil rate. The water target, it's going to be 20,000. And the gas rate target is going to be 6 million cubic meters per day. And the date that I'm going to set up my control, let me take it from here. So it's actually this one. So 31st of October 2022. I believe I need to specify it with date time. So I'm going to import date time. And I can pass a date time date 2022 October 30, if I'm not wrong. October 31. So that will be added, and then I can run again the all exports. Sorry, I can run again the output, and I'm going to actually call this gcomprod day is out of range. Hold on a second. What's happening there? gcomprod field oil rate daytime. Day is out of range. Let me verify that this is actually in the right format. Year, month, day. Oh, sorry, this is October. And now if I export to my second export, let's see what we have here. Now I have my somewhere here. Oh, I don't have a gcomprod yet because I need to, in some keywords, I also need to add the gcomprod keyword. Let's see if that works. There we go. So we have a gcomprod. So that's a very interesting way to edit the file now directly from Eclipse and or from Python. And I'll show you some of the stuff that I have done with this, so you have an idea why would you like to use this in this case. No? So for instance, I have in the final case that I have put together, I have the wconch, setup. I actually have a WAC setup, water and gas alternated. I have a gcomprod setup, and all those files I have generated automatically. The beauty of this is, I'm not going to show you at the end. This is more how I send the simulation cases. But the interesting thing with this is that I can generate many simulation files by quickly changing the controls of the case. In this case, I have, for instance, a WAP case. And I could change, for instance, when it's what is the injection rate for the water, what is the bottom hole pressure control for the water, which injectors will be injecting just water, and which injectors will be injecting also water and gas. I have the gas rate injection limit, how many days I can swap between injection and production and so on. So this is my customized function for WAC. And if I show you how it looks like on the simulation results. So let me open this case. I think I should open just in case. So if I go to one of the injectors, for instance, C4H, you can see that it's injecting gas for 182 days. First water, then gas, then water, then gas for 182 days. So simple way now I can change the 182, try what we could do, or what would be the difference if we inject for 90 days or for a whole year, or for different periods of times. So it's a bit of an idea of how we can change the schedule, and this could apply to pretty much any different parts of the ECLIPSE file. I think as a final note, one thing that I discovered from OPM is that they are introducing some Python scripts into OPM. So they have some PyAction on PyStart and PyEnd keywords. So they have 3 keywords. However, I tried to use it, and I couldn't make it work. So this is obviously a much more, let's say, integrated way to work with the actual simulator, in which you write your logic here, and you can define how to control the simulation, the simulation file. In this case, you have an action which is the maximum water cut. So when this well OP1 exceeds 80%, so the well is shut. So this is you probably will have to know a bit more of OPM and the API to control the simulator from Python when this is available. But if you have a simulation files, and you can put into work this idea of generating your schedules with and having them in tables and in data frames, and automate the generation of those data frames. One idea that I'm doing this because in the economic session we're going to generate quite a few files. So for the economic session, and we have a large number of cases that we want to create, not only the scenarios, the development scenarios, but also the subsurface scenarios. So I want to have as much control from the Python to a simulation file, so I can customize these workflows. And in fact, I have set up my own simulation server, so I can launch a simulation case, run it in the background directly from Python as well. But that's a topic for another moment, I guess. So I hope that was useful, and apologies, I got stuck with a very minor thing on the loading of the library, but yeah, that's what happened. That's what happens with these live sessions. Do you have any questions so far? Let me see on the chat. There was a question on Yamas on OpenSim. It's a commercial app. OpenSim is a commercial simulator, and you have browse on their website. So the first exercise that I put together, I was running completely on with the OpenSim results, and we could save directly. When we put that together, we could save directly into a database. Lenovo also, as you have, runs all sensitivities in Eclipse and push the results to, or yes. So with OpenSim, we were able to save the results directly onto the database. That's something that we tried, and it was working quite effectively. Sorry, I'm just replying to Lenovo a bit late. I didn't see the comment. So any questions, any comments? Well, thanks everyone. I'm glad that you managed to connect. And yeah, I think that we are done for the day. Thank you.